Cool. So, hey guys. Yeah, thanks for sticking with me while I figured that out. My name's Chad Tech. I work for a company called Chad Tech. I do front-end JavaScript freelance stuff. And I'm going to talk about how React works under the hood. So if you want to follow along on your computer, this is my repo. Where I've got my my files up. I don't really have slides, but I have about 21 files that are sort of built off each other. Let's sort of just go all the way through about, at the end we'll have like a very simple UI library that's sensitive to state. So another thing about this talk is feel free to interrupt me, or even better yet, maybe even raise your hand, talk to me. I find that very informative to know where I need to go, what I need to talk about. So I'd really appreciate that. Well, do you guys do JavaScript, or where are you guys at? Who doesn't do JavaScript? Cool. Who doesn't do React? Oh wow, a whole bunch of you. That's fine because my talk's very neutral. We're not going to talk about React specifically, but we're going to make something that looks a lot like React, and we'll start with just really basic components. So a little bit about what I've done and why I know about this kind of code is almost a year ago I wanted to make my own UI library. I really love React. I think it's great, but I had a few problems that I wanted to to get out of my UI library, and I didn't really think React doesn't provide it. And I won't get into that too much. I don't want to make this a talk about my project. Either way, I looked at the React code base, and I don't know if you've done that, but it's unreadable. You can't really get anything out of it. It's massive too. And I've read a lot of there's a lot of blog posts that talk about how React works. Those are pretty informative, but in the process of working on my own UI library, I had to run into the same sorts of questions, the same sorts of technical problems. So I sort of lived through them, and I'm going to try to share my lived experience of making a UI library that's very similar to React. Well, actually, we're going to make something that's almost exactly like React. So does that sound good so far? Yeah?
Why are we not doing React? I was hoping to learn it.
Yeah, well, I'm not going to give you like a tutorial on React, but we'll have the same API. So if you get familiar with what I'll show you, then I think you'll be in good shape for learning React. Yeah, so I guess we'll jump into this. So yeah, here's a hypothetical website. You could run this website, and it would definitely work. But I want to talk. I want to get really basic, really quickly, and then we'll accelerate quite a lot after this. This is a website, and it's HTML, and I'm assuming you guys are familiar with HTML. I'm assuming you know how to write it, but let's just talk about like what HTML is really directly. HTML elements have, as far as I can tell, they've got three properties. So they're tagged, right? Like they're p and div and different kinds of stuff like that. They have attributes like the style one up here. It's got the attribute style, and the value of that is a string. And all HTML elements have children. They have at a minimum of 0 children. And they all HTML. Well, those. Sorry, I'm rushing through this, but those are the three properties. They have attributes, they have a tag, and they've got children. And when you have HTML, let's say form a structure that we would call a whole HTML document, where there's just there's one ultimate ancestor that has children underneath it. We can call it like a tree structure, but really it's upside down. It looks kind of like roots. Yeah, you guys still with me? Sorry, I know I'm rushing really quick. So you guys all understand that, and we all know how to write HTML, but your understanding is a little bit deeper than what I'd call like the superficial syntax of this. Like you know that there's the greater than sign, the less than sign that form the brackets around each tag, but you know it deeper than that. Like you could have it in a different format. In fact, there are different formats of HTML that aren't XML. That, like there's Jade, which is like a white space HTML that transpiles to HTML. And if
Pug.
What's that?
Pug.
Pug's another one.
Well, no.
It's a new name. Pug
yeah.
is a new name for Jade.
Jade has been renamed to Pug.
Oh, really?
Yeah.
I haven't used Jaden forever. Oh, well.
No, I see. The only reason I know is I see it all the time when I'm doing stuff because it gives you the notifications. It's like Jada's been renamed to Pug,
Yeah.
and you're like, oh, all right, Pug, whatever. Yeah.
So here's that same website, but if we wanted to have it in a different format, like this is if I wrote up that website in JSON. Right, JSON is just another format. We're just talking about objects with properties. It's a little bit wordier, right? Because we actually write tag, and it has the value of body and tag, value of p. We can make HTML any way we want, and so that's kind of the first step to. We're going to just jump into rendering. But before we do that, in the description of this talk, I made one promise, which is we're going to answer the question of what is a virtual DOM. And we're going to get into that later, but this is a great point to answer that really simple, and that this is a virtual DOM. I mean, if a DOM is just storing, or the virtual DOM in terms of React or any UI library, the virtual DOM is just storing the HTML as JavaScript objects. If you can get that information and you can simulate it somewhere else, that's a virtual DOM. Since we're in JavaScript, we're simulating in terms of JSON. So stuff like this. You never see this, right, because it's just running in the computer, but that's what a VDOM is. I'm sure you've heard that if you've done any React work so far. It's just saving HTML in a different format within JavaScript. So yeah, let's actually start writing code. I was hoping to live code this, and we're going to basically do that. But there's a lot of material that I'm going to sort of run over. So I have each of these files. We're going to build off each one, and I'm going to talk about the differences as we add features to our little library. So this is down here we have a function called div, and it returns a div. And if we run div inside append child, we're going to put a child under inside the body. It's a very simple UI library, right? I think we can. I'll run this code now. Yeah, and if you see in here, run that code and it just sticks a div inside the body, right? So it's the simplest UI library, right? You just you have a function called div and it puts a div inside the page. I also have this pseudocode or this incomplete code up here, right? We talked about HTML as XML or HTML as HTML, and we talked about HTML as JavaScript objects. A lot of people have a lot of ideas about functional programming, and I don't always understand what they're saying. But we can also reformulate the objects as functions, right? You can have a function that takes tag attributes and children as a parameter. So whatever you can describe as an object, you can also describe it in a function in some sense or another. And React is in JavaScript, and you are specifying the HTML in functions. So we should be able to talk about HTML in terms of functions. So element spits out an element that has those children. We haven't written that, by the way. By the way, if you didn't know, you guys know what JSX is, right? Or if you've done React, I'm guessing you've done JSX. JSX transpiles into just JavaScript functions. So if you have, I'll go back here and just type something out. If you have something that looks like this in JSX, your transpiler, in the background, it's converting that into a function that looks something like this. Right? It's not obvious when you're actually working with React, but at the end of the day, it turns it into JavaScript. JSX is just JavaScript in HTML syntax. Right? If you know the language, you can look at it in any syntax you want, right? Yeah. So let's move on. I guess still good. No questions so far? Okay, cool.
How many cats are there?
I don't know how many cats there are. That was the question. How many cats are there? Okay, so here's a more complicated function, right? We had the div function, and all it did was it made a div and it returned it. This is a p function where we've actually given our function a parameter called text, and it's going to not just append an empty p tag, but it's actually going to give that p tag its own child, right? It's going to make a p tag, but then it's going to give that p tag a child of text. So whatever text we want to put into it. So I have it putting in the word dank into the p tag, and there we go. So there's kind of an upgraded function that takes, you know, it takes a parameter, so it's more sensitive and it's more flexible. You can put different kinds of stuff in it. We can generalize this. This is a big step up. Let me go back really quick. So in this file, so far I've had it broken down into something that, you know, it makes HTML and something that renders it, right? We can call this our render function, and we can call this part of our DOM, or, you know, this is what React DOM gives you. So in we want to generalize that, right? We want to make any kind of we want to make lots of different kinds of HTML tags. This function up here called node, it takes a tag and it gives you something that makes that tag, right? So I have node, I give it p, and now it's giving me a function that makes p tags. This is called currying. Who doesn't know what currying is? So currying is a way. It's like it's a technique where you write you write a function that gives you a new function that takes a new parameter. So rather than the example that I was given is you can translate. Sorry, I can't get too deep into this. But you can translate a function that takes x, y, and z into a function that returns a function that takes x that returns a function that takes y that returns a function that takes z. So you can give the first argument and just sort of hang on to that function. It's currying because node is a function and it returns a function that takes new arguments. I could have had node where it takes tag attributes and children, but then I would have to write node p attributes children. I would have to write node and then what tag I want. It's easier to just have a function called p that just makes p tags. Yeah, so anyway, inside the function, it takes children, and children is an array, and it appends all of those children onto the tag. And then we have its attributes too. So its attributes are an object, and we give that element all of its attributes. You guys know about object.keys? Do you guys understand that? Does anybody not understand how object.keys works? Okay, cool. So here's our oh yeah, and also I talked about that render function. Now we're actually going to just call it render. So we're going to have a function that's called render. You give it some of these functions that make HTML, and it's going to run that and stick it in the body. So at the bottom here, we're actually running a render function, and we're giving it this HTML. I really like this way of writing React. Whenever I can, whenever I'm doing React, I actually avoid JSX, and I know that's a really minority view. But it's really clean, especially in CoffeeScript where you don't have parentheses. You can just write sort of like just like Jade or Pug that you can write white space HTML with just out any transpilers at all without JSX. So yeah, we're running. Let me actually run this now so you can see what it's doing. We have this function called p, and it takes its attributes, which is the style, and we have the string that's the color that it's making it, and then we're going to give it the one child. We're going to give it a list of all its children, and its only element is the text. So we go over here. Yeah, now it's red dig. It's so moving on. Oh, this is just a little bit of sugar. Do you guys know about arguments? How you can just refer to arguments within the context of a function? Who doesn't know about that? It's really useful. So I'd be happy to tell you about it. Okay, yeah. So if you have a function, there's automatically a variable called arguments inside that function, and it's not an array, but it's like a pseudo array of the arguments that function's given. So if I have function attributes, if I refer to arguments within the function, and I did argument/0, let me just write a true statement. Attributes is the same as arguments 0. Yeah, it's really useful. If you notice, I don't have children in the function. It's because I'm just going to refer to the arguments. That way, I don't have to give it that array. I can just stick more. I could just stick arguments after the attributes. And that's what I do here. So I run through with a for loop. I run through all the arguments, and then I push it to this children array. It's really useful. Now, you don't have to do you don't have to type any parameters anymore if you know what the if you know what the arguments are. I guess that will make it pretty unreadable. But if you want to be if you don't want to assume anything about how many parameters you're giving a function. So that's all I did here. I made it simpler so you can see that text is no longer in an array. I'm just sticking it on there, and I think I could just stick more stuff on here too. So if I just put some more on here. And I put it, I run this code. Yeah, it just concatenated all the text nodes. So now our node function is just anticipating an unknown number of parameters. That way we can just stick as many as we want on.
Ding, 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 ding.
Yeah. You guys still good? Still good? Okay, good. So here's just another example of that code. Another example of our UI library up to this point, which is just a render function and a node function. It's just sticking colored divs in different parts of the file. And that's what it looks like. So we have a parent div, and it doesn't have any attributes at all. And then below that, it's got 4 children divs that have the style that puts around the page. So this isn't really a very pleasant way of typing out style. If you've used React, you know that you could actually have style and then its own object. That's some sugar I don't have typed out in here, just to keep the line number low. But this could be how React works. So part of the fun in making your own library, UI library, is you can find out all the different ways it could have been, and it's very flexible. Yeah, I'm sure there's lots of different ways it could go. So I'm going to move along. Yeah. Okay. So here's another example. Still no real progressions as to how it works in the back end. This is a simple application. It asks it offers to tell you what your Star Trek name is, but it wants your social security number. So it's a simple identity theft app. You can type in your. I don't want to type it in. But yeah, just another example. So since we're actually just referring in our node function, we're actually just referring to what the keys are in the attributes. I didn't have to write any code to say, hey, if it's placeholder, do this with it. It's just taking the placeholder string for the key, and it's taking the string for the value, and it's just sticking that onto the HTML. It has no consciousness of what it's looking at, and it doesn't need to, because you're just attaching attributes to HTML. Same for submit, for the type submit and the other input. Yeah, now we're going to do some event handling. So we have the same application, but now we've added this property of onClick to the submit. To the submit button. So it should console log Spock. It should tell you your Star Trek name in the console. It's just a prototype, right? That would be very good for the user. But how's it going to do that, right? Because right now it would look for onClick, and it would just append that as an attribute. And that's an event, right? That's different from an attribute. We want it to handle. We want it to be sensitive to events when you click on it, so you can actually run JavaScript that you specify in our little UI library. Anyway, the way we do that is really simple. So we have the keys to the attributes, and if we notice that it starts with the words on, like on click or on input, then we should make it an event handler or an event listener instead of an attribute. Yeah, it's really simple. Another way you could do it is you could look for the word. Maybe you don't want to have on click and on input. You could have event look for an object that has the keys click input. That's another way React could have worked. I haven't tested this, but if React truly does work like this, I wonder what would happen if you gave an element an attribute like onomatopoeia or something that starts with ON and just see if it tries to make an event handler out of it. Yeah, so if we run this code, let's see what happens. If I hit submit, yeah, it says Spock, right? It runs that code once. It successfully creates that event handler based off the function that we give it in the node function. Still good? Still make sense? Okay, good. I was hoping this would be too much. I think it'll get kind of complicated coming up here, so watch out. Oh yeah. Okay, so we're moving along quite a lot now. We are going to make now we're going to have like a real library, and it's called Respond. It's our React knockoff. Remember we had that render function? Did I jump to the right one? Oh no, I'm sorry. I jumped too far. Anyway, same thing. We have that. We have Respond. Yeah, we have that. We have the render function. Now we're going to build it into our library. So respond.render is our render function. Now we don't just have this free floating render function. We have. Oh man, no, I'm sorry. Yeah, I was really confused. I jumped way too far ahead. I have multiple files called event handling, so I looked for the one after that. Okay. Yeah, I'm sorry about that. So before we had our render function, we were just feeding in the sort of pseudo HTML or the functionalized HTML. To make a component, it's really simple. You just have an object and you give it the key render, and now you stick all that stuff in there. Right? Still really simple. So we have Star Trek name app, and it has this property called render. So it's starting to look like React, right? Would you guys agree? Yeah, we have objects now. And another change is the render function. It takes that component and it runs render. Like it looks for that render function in that object. Yeah. So moving along, we can also have state. So now that we have an object, we can assign state. So we're going to give it I've got this kind of useless property in there of theme Star Trek. Maybe you could mix it up and have different themes in your identity theft app. But it's now in the render function, it's looking for the theme. It says, what's your blank name, enter your social security number to find out. And we could change that to whatever we want, really. So I could do Star Wars now. Yeah, what's your Star Wars name? Yeah, so it's so simple. I mean, I don't know, React was so mysterious to me when I was just using it, but it's just a property on the object. That's all state is. You have to do some funny stuff to make everything work out right, but state is just a property stuck on the object. Yeah. Okay. So now we're back to event handling because we need to do some more complicated stuff. I want to. We want to change state now, and you can see what's going on in. So I no longer have the function just right there. I have on click, and it's this new function that I'm storing on the object. It console logs the state, then it changes the state, and then it console logs again, so we can see what happens. And you can see, yeah, it's right there. It referred to the same state. We changed it. Nothing really happened, but you can see we can access state. We can change what's going on in there. Nothing. So we've written up this rendering stuff, and we've written up a component. But a big part of React is re-rendering, right? We haven't even touched that yet. So we're going to jump into that right here. This file is called broken counter. We're going to make a counter app that's not going to work. I'm going to show you why it doesn't work. Okay, so this is the very simple counter app, right? It says counter, and it lists the count. But when we press it, nothing's changing. And if we see in the console we have the number going up, that's because I'm actually logging what the state is. And it's effectively changing state, but nothing's really changing in the application. There's a great diagram I've seen in UI stuff that says state. This is every application anybody ever makes. The state translates to the UI. And when things happen in the UI, they change state. And that's everything in terms of front end development. So
That's
we're
it.
yeah,
Go
that's
home.
it. That's all you need to know. So if you interact with the UI, you're going to change state. So we've done that so far, but state's not triggering anything to change in the UI. So when I'm hitting the counter, it's updating the state, and it stores that, but it still says 0 because that's what it said when it started, and nothing ever changed that. Oh yeah, another thing I need to mention on, so I have this function called increment, and it's referring to this, right? Did you guys use this a lot in your code? Okay. Do you?
This not state or this not props.
Yeah. What might be confusing if you've only done React so far is you can change what this refers to, or you can change the context of where it is. So I have, it's referring to this dot state, right? And it's referring to this object. But if I run this function somewhere else, this refers to a different place. And so what I have to do, I created this new function called create class. And what that does is it goes through and it finds a function. If one of the keys, if one of the values is a function, then it binds that to that object, where otherwise it wouldn't have been bound. Let me show you what happens when I don't have that. So you can see we have these console logs because it can actually refer to that state because that state exists there. But if I get rid of this, and if I run this again, they're undefined. And the reason they're undefined is because that function that we wrote, we see it as attached to the React component, but when it actually attaches to the HTML, all of a sudden the context is no longer in that component, right? It's attached to that HTML. So what bind does, if you've never used bind before, it's a real game changer for JavaScript. So this is a function, right? Any function dot bind with a parameter of C will make that function, it'll return a function that is always in the context of C. So C is a component, I give it the component, I say, hey, I only want these functions to run in the context of this component that I'm giving them. That way it never changes. That way you can always refer to the state that you declared that function in. So yeah, I just want to make sure I hit on that before I kept going. So yeah, that was our broken counter. It doesn't work because it doesn't re-render. Now we're going to have a functional one. Let me just show you it working really quick. Yeah. So yeah, we have React now. We have a React that's not going to work very well, and it's very inefficient. But you can change state, and state will change your UI, which is basically what React does. A lot of complications behind React are making that an efficient process, and this is not an efficient process. And I'm going to keep talking, and I'll show you some of the difficulties with that. But let me talk about re-rendering now. So this is our good old render function, right? It's the same one that we've always had. One change is that before we render it, we attach the component to the library as a whole. We look for this app key, and we say this is our component. That way, it actually remembers what the application is, or what the components are. So that when it needs a re-render, it knows what to look at, right? Because if it just renders the first time, it just runs that code, and then it has no way of referring to the component again. This way, we can actually remember it, so that when we re-render it, we can refer back to something. So I've added set state, and I'm guessing I'll talk about this more, but I'm guessing you guys are familiar with set state. Set state doesn't do anything complicated. It just takes those changes and it puts them into the component state. But once it's done with that, it tells the application as a whole to re-render, and then it does a re-rendering process. So we can look at our re-rendering process, and we had this super simple re-rendering process. It takes the HTML, it just gets rid of the body, and then it makes a new body and it sticks it in. And that's what's going on in here. If we look in the elements, every time we press the counter, state changes, then it knows to re-render and it just blows away everything, and you can see the HTML body flashing there. It actually has to make a whole new HTML page every time I press the plus button. It just so happens that it looks exactly like the one before, so we don't notice the changes. And React actually does that too, which I don't know, I found surprising is when you're changing stuff, even small details, it's actually getting rid of HTML and putting it in, and it happens so fast that you don't notice the change. So I promised to look at set state, and that's how we trigger it. Is I had in the previous increment function, all we did was we referred to the state, and we referred to the state, and then we made it one higher, right? But that's referring to the state directly, and then nothing. Our respond doesn't know that happened in the working counter. Now that we have this new function called set state, we use set state to trigger re-rendering. Set state, we give it a new object that has the key and value that we want the application state to have, and that's how that works. You guys still with me on this?
What's the syntax for the object.assign in the set state function?
Yeah, so that is that's a really useful one that I really like. Basically, it takes where is that? Yeah, so it takes the second argument, which is an object, and it puts all of the key values into the first argument. So this is state, and it's it's something like count 0, and change is count 1. So the output is count change count. Yeah, it sorts through the keys of the change, and it sets the value in, or it sets the key in the first argument to those values. I hope I got that right. I mean, I know I got it right. I hope I explained that well. But yeah, so moving on. Yeah, we have everything working right now, but there's something we need to do, which is we need to make components, right? Because right now we have just one big master app, and it's not broken down at all. Now we can actually break it down. We're going to make a title, and then we're going to stick that title in here. And it runs just fine. It runs just like how we had seen before. So if you notice before, the components were objects, and then we pass them through create class, and they output objects. So they've been objects for everything that we've been doing. We've changed that a little bit. If you notice that my title here is a function, right? And I run that function. It doesn't have to be a function. You could just have an object. We're going to need functions later, but you could hypothetically have a UI library where your components are just objects rather than functions. And to make them functions, I just made one small change up here in create class. Now it's not returning an object; it's returning a function that returns an object. Just like curring, how I talked about it before. So now I can run title and it spits out the object I want, rather than just being the object I want. There's another advantage with this, in that we might want a whole bunch of titles, or we might have an input field or something we're going to reuse in a bunch of places. if you have a function that spits out these objects, you actually have multiple objects, versus if you have just an object by name, you're just referring to the same object in different places, and the states interfere with each other. So I guess that's the first advantage of having a function that spits out objects here. It's also useful in props, which we'll get to in just a second. Yeah, actually, that's the next one. So here's that same create class function, except now it's actually taking a parameter called props. And just like how it's mixing in the change to the state, it's going to mix in the props into, oh no, I'm sorry, never mind. It just assigns props to the component that we feed into it. So I think we look, yeah, so we have counter container. It has the title, but then it actually has the real counter in there, and we give it these props. The increment function, which we have to store up here, and then the actual count too. So if you run this, it still works, right? And that's, I think from here on out, things are kind of more complicated than I could really code out. But that's a React library. You could use this for your clients. Yeah, again, it wouldn't be a good idea, but it would work. And if they didn't test it enough or they didn't push it too hard, they wouldn't know the difference. So yeah, any questions right here? Yeah.
I'm just a little curious. Why did you just port React?
Because it's a huge body of code that I couldn't figure out. I think a lot of the actual code in React is not doing this stuff. I mean, I mentioned earlier part of what React does is it has a very it's optimized in how it re-renders. I think another thing is if we had a problem if there was some kind of bug or something in our code, it would have an error that would refer to the library, and it probably wouldn't make sense to someone who didn't make it themselves. So I think also React, a lot of the React code base is just looking for mistakes that someone might have made, and then it's throwing you errors. Yeah. Yeah, so here's that little diagram that I mentioned earlier. I code in Elm as much as I can, by the way. That's an Elm thing. Anyway, so we had this is basically some pseudocode to the render function that we've been working with so far. Step 1 is remove all the HTML, and step 2, or also step 1, is it just make all new HTML. Just replace it. Just make the entire application again. But there's a problem with that's really wasteful. I mean, 99% of the time when you're changing state, almost nothing is actually changing in your application. Like the UI doesn't really change very much for specific changes, at least most of the time. Also, another problem that we'll address later, but actually referring to HTML elements is actually a pretty costly operation. I mean, making a new HTML object or grabbing one and then removing it takes a lot of CPU cycles. And a lot of people will downplay performance. I always talk about performance. People always tell me it's not important, and they're right, it's not important. But if you're making your own UI library, it becomes a problem where if you make the simple application we did, you will hit the limits of performance. You need to optimize it once you're actually worried about how things render. Yeah, interacting with HTML objects is costly. We need to minimize that. We're going to minimize it later. But to the extent that we could avoid touching HTML, that we'll get some real returns from that. So yeah, okay, anyway, the solution to the first problem that I mentioned is that you don't need to change everything. The solution is really simple. You only change what you need to change. So here's another possible render function. We're going to render a virtual DOM instead of just rendering HTML. So remember what I talked about, what a virtual DOM is at the beginning? It's just HTML, except you're storing it in a JSON file format, or the JavaScript has it as JavaScript objects in the back. If you generate JavaScript objects, those are really easy to work with. They're a lot easier to work with than HTML. So we need to generate a virtual DOM and then compare it with the HTML. So we have the HTML, and then we've changed state, and so then we generate a virtual DOM with the new state, and we know that they're going to be different somehow, so we we need to sort through the entire tree of HTML and see where they're different. And then we need to make only those changes. This is a really open-ended problem because there's a million different, ways you could do it. Either way, yeah, that's what we need to do. You guys still with me? I think it's getting complicated now, yeah?
Are you saying you need to write the code for that, for the virtual DOM?
Yeah, or we do right now if we're going to make our UI library. You don't need to do that as a React user. All that happens automatically. I don't think you even really need to know what a virtual DOM is. There's something else. Anyway, yeah, so I'll just keep moving along. Here's our HTML. Let's say that we change state and then we generate a new VDOM based off that change in state. You can see the changes. So we have the div no longer has a third child, and the child of the second P has changed from dog to cat. So we need code that identifies the changes, and then based off the nature of those changes, we need to re-render in specific ways. We need a render function that's specific to changes, whatever those changes might be. So here's our new pseudocode render function. Well, we know that there's no longer a third child in the VDOM, so we need to get rid of this one. We need to have a function that looks for that HTML object and then gets rid of it. And we also need we need an operation that's going to look for this element and it's going to replace it with this one. It's going to replace it with the updated text. So that's how that works. And let's flesh out that diagram, right? This diagram right here. This is just a line, but a lot of stuff happens in that line. So this is a more elaborate version. There's an interaction, and that affects state. But state translates into a virtual DOM, and then you need to compare that virtual DOM to the HTML, and then you need to render sensitive to the differences. Like, you need to generate differences based off what it needs to be, and then you need to render based off those differences. I know that get a little tricky, because we're about to complicate this even more. Yeah, I'll just keep going. So it's still it's still costly, because remember how we talked about how costly it is to refer to HTML directly? When you're comparing it, you need to look at every single HTML object, right? And that's not very efficient. So it'd be more efficient if we can compare two virtual DOMs. And that's a better way of doing it. It's cleaner. There's a little bit more code, but it just the flow's a lot better. This is a little bit too big. So here is a even more elaborate version of that previous diagram. One thing I forgot to hit on is, remember our old components? When you run the render function, it just gives you HTML. If we were to keep coding, we would change that so that when you run those render functions, they give you VDOMs, right? And then you have a separate function that translates the virtual DOMs into HTML. So that's one change that I haven't really demonstrated in code. I think I might have some files later. Anyway, so yeah, you run the render function right when it starts, and you get a virtual DOM, and then you translate that virtual DOM into HTML, and then you keep the old virtual DOM, because you're going to have another change, and you need to compare the two, because it's a lot more efficient to compare two virtual DOMs than it is to compare virtual DOM with HTML. And also, if the HTML is just an expression of the virtual DOM, then they should be identical, right? They should map one-to-one with all their properties. So yeah, let's walk through it again. The user interaction, that's going to change state, going to generate a new virtual DOM. Then we're going to compare it to the old virtual DOM and find the differences. Once we've identified the differences, we're going to update the old virtual DOM with those differences, but we're also going to change the HTML with those differences. So if we can identify the differences between those two virtual DOMs, then we should be able to find the point in the actual HTML that those differences correspond to, and then just change those elements. So I don't know if they actually do this in React anymore, but they used to. If you looked in the HTML, all the elements had these little tags called React ID, and then it would be sort of like an address. That's how it would find the right ones to change out is because it found the differences in the VDOMs, and the VDOMs had an address, and then they knew that these virtual DOMs correspond to these actual HTML elements that have the same ID. So they would just look for the element that has that ID. And if you've ever been wondering what those IDs refer to, that's how it works. Still with me? Still, yeah?
Why are you doing the different, why don't you just change the API directly? Just keep the new dominance itself. Why are you determining the differences? Is it faster? Or?
Yeah, it's faster, because if every time we refer to the HTML, it's an operation, and that operation happens to be very costly. So this way, we only touch the HTML after we've established the differences. If we diff the new VDOM directly with the HTML, every time we compare the elements to establish if there's a difference, we have to refer to the HTML element. So this minimizes how often or how much the HTML is actually getting touched.
So the actual physical embodiment of the HTML here is an internal data structure that you're getting at with the normal browser examine elements type of stuff. Is that true? Describe precisely what you mean by touch HTML.
Yeah. Okay. Great question. So there's a whole number of functions like append child, get by attribute, new element. Those are the functions I'm talking about. Something that creates actual HTML or modifies actual HTML or makes any reference to it at all.
But at this point in the discussion, actual HTML is probably an internal data structure in the browser.
Yeah, right. It's just data structures talking about other data structures, right? Yeah.
But it's slow.
Well, one problem that I had when I was working on my UI library was the functions have context, right, or they're referring to something. So I would change the event. I would assign a function to an event handler, right, and then I would change something in the virtual DOM. But that function that's stuck to HTML was attached to a component that got garbage collected or got thrown away. And so now it's just sort of suspended in the void. And whenever I run it, it changes the state in this thing. But this component is now totally disconnected from the application as a whole. So I learned that I have to diff event handlers too, where I have to do something about that. I don't have that up here, but you know, there's a lot of little micro concerns that show up that I'm not really diving into.
So why you rewrite your own?
I'd love to answer that. I don't know if I have like 15 minutes. Is that true?
When is it over?
I don't know. Let me finish up these and then I'll answer that question if I've got time.
Yeah, about 15.
15. Okay. Thank you.
Word.
Here's some simple coding. Here's a simple diff code example. We've got VDOMs up here, right? Old VDOM, new VDOM. Comparing them can be really simple or surprisingly simple. We just need to turn them into strings, and then we just compare the strings. Are they equal? Right? Because if one attribute changes, then there will be different strings, right? The only way they could be identical strings is if they were identical in all their tags, attributes. So I don't know if you guys can understand what's going on. This is called stringify. We give it tag and attributes, and then just create a string where the first character or the first characters are the tag, and every character after that is one of its attributes, or the key and it's an attribute. Yeah.
What if the order of the attributes changes?
Yeah, good question. Sometimes the attributes will be in different order, and it'll recognize those as different, even though they're the same, they're just in different order. That's possible. I ran into that problem when I was working on my library. I think I just made it, it always sorted the attributes every time I checked them to guarantee that they would be in the same order if they were the same attributes. Any more questions about this?
How long does the old virtual DOM stay in memory before garbage collection picks it up and throws it out?
I don't know. So I don't know how the V8 engine works internally, but you'll have, it's like a tree of objects, right? And you'll disconnect one of them, and then you'll substitute it with a new one. And I don't know what happens to that other one, but yeah, you won't have anything that refers to it anymore, and I'm pretty sure that triggers garbage collection.
Okay.
So yeah, there's no like lingering VDOMs. As soon as it's no longer in there, it's disconnected, and then I guess garbage collection gets to it. Merging, right? A lot of people talk about UI libraries and they just talk about diffing. They say diffing is rendering or re-rendering based off state. When I got into this, I found that diffing was one term, and there's a lot of other things going on. Diffing as a process, we just talked about diffing. Diffing just tells you things are different. Diffing doesn't render HTML, so you need to find differences, you need to merge differences, and then you need to render those differences. So this is kind of like a diagram if we were working through merging differences. So we have two VDOM elements. If they are not same tag, we know we need to do something about it. If they are, we can move on to the attributes. If they have the same attributes, then we don't really need to worry about anything because it's identical. But if they don't have the same attributes or they don't have the same tag, then we need to take all the children of the old VDOM and give them to the new VDOM, and take the children of the HTML and also give them. So whatever, that was complicated. Let me draw something other. We have a node here. So this is a div. How's it be? We have a div, and it has another div, and this one has 2 p tags. If we find that there's a difference in here, we need to change this middle div. We can't just get rid of these HTML objects, right? If this was HTML, we can't just get rid of these. And if this was the VDOM, we can't just get rid of them either because they correspond to the HTML. They have like a connection with the HTML. We need to get these children, get this parent, get rid of the child of this parent by referring to this parent, make a new div, and then give this div the children that we saved somewhere else. I don't know if it's clear why you need to do that. If you get rid of HTML without changing the VDOM, then they won't be connected anymore because the functions that are attached to the HTML are in a VDOM. And so if you get rid of a VDOM, if you get rid of one of the other, things will become a mess. So if you change the VDOM, you have to change the HTML in a corresponding way. So this merge is describing that if there's only a change in the div and you don't need to get rid of the children, you need to save the children somehow. You need to save the children, and then you need to assign them to its parent. So you don't want to garbage collect these because you're not going to garbage collect the VDOM. You need to have them around so you can give them back. Or you could, it'd just be inefficient. You just need to make sure that when you change the VDOM, you're always changing the HTML in a corresponding way, and vice versa. So here's some more pseudocode. Right, this is our old one of the cool cat and cool dog example. And this is sort of just talking through what the differences are. So we have the same. We have the topmost ancestor. They're the same, so we don't need to change anything. Then we just go through all of its children. These two are the same, so we don't need to change anything. The text in them, they're the same, so we don't need to change anything. In the first one, the actual attributes of the p tags are also the same. We don't need to change them, but then we notice that the cat and the dog are different, so we need to take these differences and merge them. We need to remove dog and add cat. And for the final one, we notice that the child is gone, right? We compare p with undefined, and we say, oh, there's nothing we need to replace it to. This is just lingering HTML. We need to get rid of this HTML. So this is sort of some pseudocode about merging VDOMs. Any other questions? I feel like this is frantic, and I hope it worked out for you guys. Yeah?
One about that example. Would it be better if you made it into a looping structure where you don't know how many p tags are going to be underneath?
Yeah. So I don't know if loop's the right word, but it is recursive, where you have merge, and then you sort through the children. You have merge and you give it an element, and with that element you have children, and you apply merge to all of those too. So the merge function is going to sort through the entire tree until it gets to the bottommost element that doesn't have any children. And there's got to be one of those at least. Otherwise, it's just something.
But that example actually has the hard subscripts. 0, 1, 2.
That's just pseudocode though, right?
Yeah, that's just pseudocode. Yeah, it's hard coded, but it would sort through on its own. And that's all I've got. So yeah, I really thank you for attending. This is my Twitter and my email if you want to talk to me about this stuff, or you can just hang out and talk to me about it too. I will take any general questions about this. And also, you asked a question, right? About well, yeah. So I'll answer that really quick. Redux is a thing, and I didn't really like Redux, so I thought that out really hard, and I wanted to come up with my own solution. So I made a UI library that's very similar to React, but it manages state differently. There's like a universal state, and I tell which component. Each component specifies which part of state it's sensitive to, rather than having component level state. That's really simple. It's on my GitHub too if you want to look into it. Yeah. Any other questions?
But why you people like this?
Redux? I probably disagree with everyone on this. I don't know. Maybe I don't have the best judgment. It just seems like a whole lot of code, and I couldn't really figure out what the advantage. There's a lot of overhead. There's a lot of infrastructure to do something that I never found to be a big problem to begin with. I have a description of the problem that I'm sure everyone disagrees with, but yeah. I think hopefully that addresses what you're talking about. I have a GitHub repo that explains all this a lot better, but yeah.
So I've kind of followed you through the past year as far as doing your rebuild, and when you first came up with the idea of doing Himasama and everything, one of your biggest issues was that of context. After building your own library and seeing React context and what you have built with your library, can you see the functional uses of context now?
Well, I don't. So there's a thing in React called context, which is fairly new, but everything in React is fairly new. That's just sugar for props, right? It just says this is props all the way down, so you don't have to specify it.
It's a parent-childless relationship.
Yeah, so I mean that's really useful.
Yeah.
But yes, it's not enough, right? You don't need that instead of Redux. Any other questions?
Do you have this problem statement from the solution on GitHub, the one you explained?
Oh, the code I showed?
Yeah, that you think the merging stuff?
Yeah, so I have, here's the link to the repo where I have all of this that I've talked about. But if you want to look at my my UI library, it's also on my it's under my name also, but it's called Himasama. So look it up. Cool. I think I took it the whole time. I was worried about before and after. So. Well, yeah. Thank you so much. I appreciate it.